Hello, my name is Sine and today we're learning about trigonometry. The first thing you should know coming into this is Pythagorean theorem. A squared plus b squared equals c squared. That is the first thing you should know when coming into this. It also has to do with right-angled triangles. C squared is the hypotenuse. That is what C is. A and B are either side. This could be A, this could be B, whatever. And when you add up the sides of A squared and B squared, you get C squared, which is good when knowing about Pythagorean triples. Pythagorean triples are a set of three numbers that follow Pythagorean's theorem, like 5, 4, and 3. When you add up the square root of 4 and 3, which is 16 plus 9, you get 25. Square root of 25 is not a decimal number. It is a whole number, and that number is 5. Alright? You understand? Alright, good. Just erase this for now, and we'll move on to the big stuff. The stuff that you probably are expecting. The trigonometric functions. I'll leave this here for now. Okay. When finding out theta, which is a variable for degrees, this is theta degrees. And let's say this is the hypotenuse right here. This is the adjacent side, and this is the opposite side. What I want to find out are the trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. And here's how you find sine theta. I'm going to show you how to do all of these. So we're starting with sine theta, which is the opposite side over the hypotenuse. I'm going to write it OP, P, over HYP. Next up, cosine. Adjacent side, this time, the side adjacent to theta, is over top of the hypotenuse. Now, tangent theta is different, because tangent theta is sine theta over cosine theta, which cancels out both heights and leaves us with the opposite side over the adjacent side. Moving on to cosecant, it is the same as sine, but you flip them. Instead of opposite over hypotenuse, it's hypotenuse over opposite side to theta. Secant is to cosine as cosecant is to sine, which basically means just flip them. Hypotenuse over adjacent. Now we got cotangent. And this one is the flipped version of tangent. Or another way to write it is cosine over sine, because the hypotenuses cancel out. It's adjacent over opposite. For now, Finding out the trigonometric functions is all that matters, except for one more thing. Let's say you want to find out what is theta. Like, what is theta? No. You know, sine to the power of 1 theta is equal to opposite side over hypotenuse. Now, let's negatify it. Let's turn it from a regular to a negative. So, let's first of all isolate theta, and then have it be sine negative 1 of opposite over hypotenuse. That is how to calculate theta. Not theta degrees, right, which to calculate degrees would be theta times pi over 360 equals theta degrees. No. This is for theta. There is no degrees. All right. Let's just erase all this. Now let's get an example. This time, example of a Pythagorean triple that we can use to calculate the trigonometric functions. You can use this as a reference. You can use this side as a reference when solving the right side. When solving the question I give you on the left side, you can use the right side for reference. Just let me finish erasing all this. And there we go. The hypotenuse, for example, is 5, which is the Pythagorean triple I gave you earlier. 5, 4, and 3. This is theta this time, which means this 4 right here is actually the adjacent. I'm trying to trick you up. This one is the opposite, and this one is the hypotenuse. Let's calculate the functions. Sine for theta is opposite over hypotenuse. 3 over 5, or if you want to use decimals, 0.6. Cosine time. Let's take the adjacent side and the hypotenuse. And it'll be 4 over 5, or 0.8 if you want to use the decimals. We're moving on to tangent, which will be opposite over adjacent, which will be 3 over 4, or 0.75. Cosecant. which is the opposite sine. So it's 5 over 3. Or, if you want to use decimals again, 1.6 repeated. Right. Let's get to secant, which is the opposite of cosine, or the flipped version of cosine, 5 over 4, or 1.25. All right, let's get to cotangent. Cotangent is 4 over 3, or 1.3 repeated. And now that you have them all, we can move on to our next example. I'll give you a few seconds to take it all in. Just start by erasing this. I'll give you some time to keep it in your mind before we move on to the next example. Because this example, it's going to be bigger. And it's going to be better. I'm still going to keep the formulas up, just in case you still don't know how to solve, or you just need the formula. I'm not taking this away because it's good to have it on you when solving. This is going to be the last example, and hopefully you've enjoyed this video so far. Sorry for the long wait, but it's time. Final one. Let's go. This one will be 25, 24, and 7. The theta will be here. So this will be the opposite, and this will be the adjacent side, and this will be the hypotenuse. Side theta. Alright, sine theta is equal to the opposite side over the hypotenuse, which is 24 over 25. Cosine is adjacent over hypotenuse, 7 over 24. Tangent is opposite over adjacent, which is 24 over top 7. Cosecant is the flipped version of sine, 25 over 24. Secant is the flipped version of cosine. Just put the thetas in here. You should always remember to include the theta when doing it. Do not make this mistake that I made to teach you, because it can't just be the tangent for nothing. has to be the tangent for the angle, which is theta. As you can see, theta, 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 theta. Okay, back to it. Also, my 5 kind of looks like a 4, so I'm going to change that. Instead of it being 7 over 25, it will be 25 over 7. Just fix this 7 for you. And lastly is cotangent for theta, which will equal the opposite of tangent, or the flipped version of tangent, 7 over 24. Alright. Hopefully you did that example correctly. If you did, then make sure to share in the comments how you did. Say if you understood it or you didn't. As this is the end of the video. Well, it's near the end of the video. I'm just erasing this. I'm keeping the formula up as I do my outro, so you can still keep this in your head. If you already know how to do this, it's good to reinforce it into your brain. And now, for my outro. If you liked what you saw, feel free to subscribe. Subscribing really helps my channel grow. And I am not the biggest YouTuber right now in terms of the time me uploading this, so it'd be great if you to support me. Also, make sure to leave a like on the video if you did enjoy, similar to subscribing, but more specific. Comment down below how well you understood this, or if you got my example questions correctly. It's always nice to leave a comment, and it doesn't hurt at all. Lastly, if you know anyone who wants to learn more about trigonometry, feel free to share this video with others. It could be your friend, it could be any of your siblings, it could be your cousins, maybe just someone who shares similar interests to you. It's always nice to share videos. So don't withhold information. Make sure that everyone gets to have the same opportunity to learn. Thank you all for watching. And I will see you all later.